Okay, so now it is my pleasure to introduce the director of Desert Moon, Jason Davis. Jason completed a master's here at the U of A in journalism, and Desert Moon was actually just a part of your thesis. He is the creator of several digital publications, including Scientific Tucsonin and Sky News, and currently works as a digital editor for the Planetary Society, the world's largest nonprofit space interest group, where he covers the Society's light-sail spacecraft and reports on human and commercial spaceflight. Welcome, Jason.
Yep. All right, so I'll thank you very much, and I will bring up our esteemed panelists here. We're going to have a little discussion about space imaging, some of the stuff you saw in the film, all the way up through what's currently going on in the field today, including the stuff that's happening right here on campus. So let me start by bringing up two of the stars from our film, and I'll just go left to right here. Make sure so the first one is Robert Strom, and Bob, I didn't know how to introduce you. I was trying to list all the spacecrafts that you have worked on, so I just said countless spacecraft missions, including some that we saw in the film and many more after that. So Bob Strom, everybody. Next, 3 seats down, our other star from the film. Same thing, resume too much to list in a short blurb, but he was a planetary scientist with Ewen, with Gerard Kuiper at the University of Chicago and the University of Arizona, and played the key role there in finding the Apollo 12, the Surveyor 3 spacecraft, which became the landing site for Apollo 12. Ewen Whitaker, Dr. Ewen Whitaker. Come on up. And then we have two scientists here from the HiRISE experiment aboard the Mars Reconnaissance Orbiter. I'll start with Dr. Alfred McEwen. He's the principal investigator of the HiRISE camera that's currently aboard the Mars Reconnaissance Orbiter. And you've been going now for, what, 9 years? The spacecraft's been in? 9 years. So Dr. Alfred McEwen. And last but certainly not least, we have a targeting specialist for the HiRISE camera, and she is responsible for telling the camera exactly where to point and what to do, so that's a pretty cool job. This is Kristin Block. All right, so I thought that we could start with one of my favorite scenes from the film, and it's a little understated, but there's a moment there where you see Ewen Whitaker, Gerard Kuiper, and Gene Shoemaker all huddled around the table, and they're squinting and pointing, and it's right when they're playing that campy music where the Polaroid prints were developed and returned from Goldstone. And that was a huge moment in planetary exploration. That was actually the first time anyone was looking at pictures of a planetary body taken by a spacecraft. So, Ewen, you were there. What were you doing when you were hunched over the table there? What were those tiny little things you were looking at there?
When you tell me which button to push, I'll tell you.
When we figure it out here. You might be on already.
Sorry about that. I can't remember at all. It's too long ago. I don't remember the little bits down there. But it's just a setup for the people at Goddard in California to photograph us as though we're doing something. And we weren't. We were just sort of putting ourselves to make a picture.
So there you have it. My film is a fraud. I showed you documentary events that are actually staged. so I lose my credentials there. No, but at some point there, you were looking at really small photographs, right? You were looking at a sheet that had 4 of them on it, and these weren't like big, pretty pictures of the moon. These were just tiny little and they were Polaroids, right?
Yes. Oh, this is the one that took the pictures of the landed surveyor.
No, I'm talking about the ranger. As the ranger was
Ranger.
coming down, yeah, and taking those pictures, and then
Oh,
you were
that's
just
it.
seeing the tiny little pictures.
Yeah, we weren't watching them in actual time. We were at out in the
At,
desert
JPL?
there. JPL, yeah. And we were just listening to the recording or the various. I can't remember. I got a good excuse. I'm nearly 93 years old. Second childhood. Looking at that movie for the second time, I give up all hopes of ever getting to Hollywood. Certainly no Cary Grant.
So the point I was going to make is that they were taking these little Polaroid pictures as a backup, as the pictures were coming in real time from the television camera, and then you would get the actual photographs developed later.
Yeah,
Do I have it right on that
Yeah,
one?
we saw the pictures later. We had to wait.
Okay, so I have this much credibility left now.
Yeah.
All right, so then on the other end of the spectrum, Alfred, I assume it's still done the same way, right? You're sitting over at the HiRISE Operations Center taking Polaroid pictures as they come in live from Mars.
No, our data comes in and it's processed automatically, pipelines. When I was younger, I used to spend weeks processing images by hand. Now it's all done automatically. You get up in the morning and there's 12 new images.
And so, Kristin, you get to tell the spacecraft where to look for or where to point for these pictures. And so, I have a DSLR camera at home. It looks like it's fancy, and I can take a picture of a bird. It sets all the settings for me. So I'm just going to assume that HiRISE works the same way.
It's
it does it all
nothing
for
like
you.
that, yeah. So we have to tell, it's not just a point and shoot camera or even a fancy DLSR that I have no idea how to use whatsoever.
Good now. I don't
Actually, the camera on my phone is the most sophisticated camera I have in my life besides HiRISE. We need to part of my job is to try to explain to HiRISE what the surface is that it's going to be looking at. If there's going to be frost coverage over the surface, or if there's going to be a lot of dust on the surface, or hopefully not too much in the atmosphere obscuring the surface that we're trying to look at. And so it can tell, so that it knows how bright the surface is that it's going to be looking at, because it can't automatically adjust for those types of things. So we have to make educated guesses about how much, what the conditions on the surface are going to look like. So we need to be really aware of what the weather is like on Mars, about what season it is on Mars right now, about how far the polar ice caps are extending at the moment. So you need to be kind of aware of what's going on a different planet to really get the images in that you want to get in.
You just probably turn on the weather channel like most people do in the morning, get a weather report from Mars.
We actually do get a weather report from Mars.
Okay.
That is
Okay.
the case, yes.
And do you ever blow it, for lack of a better word, like you get back this picture and it's completely overexposed, and then Alfred frowns when he gets up in the morning and his 12 pictures aren't these gorgeous shots that we all see out there at the in the exhibit?
Images can go wrong for a number of reasons. Oh, I'm really glad to hear that. He said not very often, for those of you who couldn't hear. But more often than us blowing it, because we have pretty extensive processes to kind of help us not to do that. More often than that happening, we'll have something like there's a lot of dust in the atmosphere, which happened to us pretty recently. We had a pretty unexpectedly dusty time, and it ruined a lot of images for us for a little bit of time, which was a little bit of annoying.
Alfred, were you going to add something there? Okay.
They do a great job.
So, Bob, I'm going to have to move over to you, and since I haven't asked you anything yet, and I have to point out, for those of you that don't know, Bob Strom has been to Mercury twice. Not many people can say that they've been to Mercury twice, or through a spacecraft, though, right?
Through a spacecraft. That's for sure. The Messenger mission, that's in orbit now around Mercury, and it's about ready to come to an end. It's scheduled to crash on Mercury in the 16th of this month. It's been lowering the orbit. They're running out of fuel. It might go a little longer than that. Who knows? Anyway, it was only designed to do 1 year in orbit, and it's done now 3 years in orbit, a little over 3 years. And it's a great spacecraft. And the other visit to Mercury was Mariner 10. That was back in the early 70s. And finally I got to see, we only saw one side of Mercury. These were flybys, 3 flybys, and saw one side only. And I waited, and I thought I would never see the other side of Mercury, never see it. And by God, I lived long enough to see the other side. Looks just like the first side. There wasn't a big
But that
difference.
tells you something as a scientist, right?
Yeah, it does. Yeah. I thought it would be different because, like the moon, the 2 sides of the moon are very different, but not Mercury. Well, there is new things. We saw, of course, the high resolution, much higher resolution on Messenger, and saw these little hollows that were very intriguing, still are, probably due to volatile escape of some kind. But there's a lot of new things we've seen. So it's not like didn't see anything different from Mariner 10. We did have seen a lot. We have a lot of new data. So it's been great.
And Bob, something I noticed before I came in here, I was just quickly Googling some pictures from Mariner 10. And for those of you that haven't seen some of these older mosaics that are shot, it kind of looked to me like a picture of Mercury displayed on a fish. And meaning there were individual scales that were kind of, so that kind of matched, but it kind of didn't. But in your new pictures of from Messenger, I don't see that.
No, that's all done by computer now. At that time, Mariner 10, we had to do it by hand. The computers were not sophisticated enough to blend them all in together. So that was all done by hand, and scaling and so forth. So you'll see that there are different sizes because the spacecraft is flying by at high velocity, of course. And so you get different sizes and different resolutions, actually. So that's what was all put together. And that one that you see, that's the Caloris Basin, which is the largest basin on Mercury. And I was given that after the mission. They gave that to me. And that was the last mosaic that was done professionally by an imaging team. There has been mosaics made afterwards, but that was the last one. And it was it was fantastic. It was really good. Those are all television images, by the way. At one of our meetings, one of the team members from JPL came in and said, we have a new imaging device called a digital image. Isn't that amazing? They said, I think we can fly it, That was, he brought in and showed a picture, and it was, the biggest they had at that time was, guess what? 10 pixels. That was it.
So pretty much the same as the 10 megapixel camera that comes on a phone.
10 pixels. But they said someday it's going to be much bigger, and we'll fly those, and we did.
So I wanted to talk a little bit about some of the challenges that we saw in the film, the challenges of getting these images, and then the challenges that we still have today getting some of these images. And Ewen, we saw in the film where Surveyor had landed, Surveyor 1, and they published an article, said that it was right at this spot on the lunar surface, but then you were able to say, No, it was in a different spot. And then we had the scene where you were going around with a magnifying glass. So why was it so hard to find something that landed on the moon back in those days?
Well, you're mixing up two different surveyor missions.
My credibility just shrunk again.
Well, that's okay, you're allowed. I'm supposed to remember it all. In the case of Surveyor 1, the group at Houston worked out where they thought it had landed from the surveyor, which had radars pointing at the ground, and so they knew the altitude. And what happened was that the cameras on Surveyor 1 looked around. They were told to look at the scenery there, and in the distance on the horizon there were some sunlit peaks, a range of mountains, the edge of Flamsteed crater. So they worked out where they thought it was from the reflection of the radar on the craft onto the lunar surface, and then they could pick up the distance away it was and say it had landed here. But when I did it more accurately from some of our Earth-based photographs of the moon that we'd taken up in the Catalinas, I thought there's something wrong here. One of the things they did was to pick out two little craters there. They thought these must have been the reflecting craters. I don't know exactly what they did. But also in the pictures sent back from the orbiter, which had already photographed it some months before from orbit, showed somewhere near where they thought the surveyor had landed, two little dots which corresponded to the reflection of these two radar beams as it came in at an angle. And I worked it out. I thought, they're not right. These little bright craters on the orbiter pictures must be fresh craters with rocks in them, and that's why we're getting a better radar reflection from these craters from the nondescript things that the people at the JPL thought they were. So I wrote the article, sent it to Science magazine, and it was published, of course, and it was found out later that my identification was correct and theirs was wrong. So that was very pleasing.
I can imagine.
So earning my money.
So you're triangulating from what the spacecraft is telling you as it comes down on radar, in addition to what you're seeing from orbit and from ground-based telescopes. You're using three sources essentially.
Exactly.
So if I could ask Alfred and Kristin how that changes on Mars when we're trying to find the position of a spacecraft, because I know that they ask you a lot to find what the rovers are up to.
Yeah, it can be tricky to figure out where you are from the images from a lander, a rover. And this was done for like the Viking landers. And they worked out as carefully as they could where they thought they were located. And then we had some pretty high resolution images from the Mars Global Surveyor, from the mock camera, that identified features that they said were the Viking landers. But then when we came along with HiRISE and took our pictures, we realized that things were moved around a bit. What they identified as the lander was the back shell, for example, at one of the landing sites. And so we cheated. We just got very high resolution images. We could see, that's it. You know, it was easy.
So, and how often are they asking you to photograph these like Curiosity, for example? How routinely are you taking pictures of it?
We take an image of the Curiosity, the Mars Science Laboratory rover, about every month or two, just to sort of check up on whether any dunes or anything is changing nearby. We just got an image yesterday, in fact.
And it's a great one.
Yeah.
Ooh. When will we be able to see it?
No, next week, I would guess.
Oh, come on. Just kidding.
Or come right out. Right? I'll show it to you. I mean.
And you also have captured things with HiRISE actually in motion, both spacecraft and processes on Mars. So first, maybe the spacecraft piece of it. Kristin, how did you, or were you involved in the targeting piece for the Curiosity landing?
So a tremendous number of people were involved in that, both at University of Arizona and JPL and other places. And it was an incredible, I don't want to say feat because that makes it sound like luck wasn't a tremendous part of it. And I really think that luck was a tremendous part of being able to capture that descent image. Yeah, a lot of us were involved in that. And part of the way that happens is JPL does extensive calculations to figure out where their spacecraft is going to be and at what time, which means they need to know what their spacecraft is doing with pretty high accuracy and precision. And then we point in that direction, and we hope that they're there, and we hope that we can point there with some accuracy, and we take an image and hope that it's not too blurry, hope that everything lines up quickly. The fun part of an event like that for me is staying afterwards and waiting for the data to come in. And usually for the everyday Mars images that I take, I wait for them to come in and be fully processed and see them, in a couple of days. And they're fantastic and wonderful. But for something like that, a bunch of us stayed and watched as each channel of data came in, and we really pored over them and combed through them to try to see if we could, see what we could see to see if we captured anything at all, because we really didn't know what it was going to look like, if it was going to be a speck or if it was going to be obvious at all, and it was, and you've seen the image in it.
And for those of you who haven't seen it, it's a picture of Curiosity under parachute actually floating down to the surface, but hopefully you've all seen it. If not, hirise.lpl.arizona.edu.
Or UA-hirise.org is easier.
That's
to
a little
remember.
simpler. So I don't know how we're doing on time. We're still okay to go a little longer here? Okay, so one more topic I wanted to cover before we open it up to some audience questions is colors. And since we're talking about imaging and all the pretty pictures that are out in the astronomical gallery, so I'll start with you, Alfred. I have this awesome poster on my office wall, and it's from the HiRISE team. And it shows Mars in these brilliant blues and whites and reds and tans. And then I see Curiosity taking pictures, and everything, it doesn't look blue or any of those pictures. So, are you cheating us?
Yeah, we're fooling you. HiRISE doesn't have human eyesight because it's easy. You can see through the dust better, shifted to longer wavelengths. So we're more like Landsat, where it's infrared color, and then sometimes we have fun and enhance the colors a bit too as well. So since it already isn't natural color. By the way, Mars is a very bland target for this idea of Dennis Tito that we're going to send somebody just to fly around Mars. They're going to look out and go, "Oh, is that it?" It's it's all bland and sort of dust colored. It doesn't look like that to our eyes.
But you do take color, like true color, or how do you make a true color image? The non-enhanced ones.
We don't claim to make natural color images, which are red, green, blue, like we see with our eyes. We can radiometrically calibrate it and tell you what the exact numeric value is in each channel. But so it's true color information, but we don't attempt to make the pictures look like they would look to our eyes. In particular, not only if the target would be extremely bland if we didn't stretch it and enhance it. You'd look at it and go, well, why did you bother taking that picture?
Bob, I wanted to ask you, you've worked on so many missions over the years. Which to you is the most visually appealing mission that you were a part of, where you actually saw the best things coming in?
Oh, that's a very difficult question to answer, because they're all good. I mean, I love all of the planets and the satellites. I just love it. I think one of the most exciting was the Voyager mission. I was on the science team for that, and going by, seeing Jupiter and its satellites for the first time really close up, and then gone to Saturn and Uranus and Neptune, and seeing those satellites for the first time was mind-blowing. It really was. particular things like Io, which is volcanically active. It's the most volcanically active body in the solar system. And to see that, I mean, we were just, well, I would say shocked, absolutely shocked at it. And we said, boy, there's been a lot of volcanism back there. And then as the spacecraft pulled away, we took pictures going back, and for God's sake, here was this big plume coming out, you could see. And we located where that plume was coming from, and it was a very prominent, kind of a heart-shaped, dark area, black, dark-shaped ejecta coming out and landing, and that was just, well, I can't tell you. I mean, we were just ecstatic. Here it's active right now, you know. We thought everything was dead, you know. It wasn't at all. And the same thing now they're finding from on Enceladus and even Ganymede. They probably think there's subsurface oceans on that with some activity coming out. Europa is another one. So that was, you know, really an exciting mission. But they're all exciting. I mean, every one of them. Messenger was exciting as can be, and so was Mariner 10 and Apollo. I mean, what can I say? I mean, that was just unbelievable. I mean, I get tears in my eyes thinking of that. It was so fantastic to see the first landing and to realize this is the first time that humans have been on another planet, the very first time. I mean, it's just unbelievable. And that legacy lives on, you know that. The legacy of Apollo. It's still active. You say, wait, no, it's not active. Yes, it is. The science is still active because they brought back a lot of rocks, and those are still being studied today. And without those missions, we would not know very much. There would be big holes in our knowledge of the solar system without that mission. We learned now what the age of that surface was from the rocks returned and things. The science is still going on from that mission. And the other legacy, of course, is philosophical, isn't it? Because I'll never forget the image of Earth taken from Apollo 8, which didn't land, went around. Now, that was not the first image of the Earth taken from the moon. That was the orbiter did that. But this was different. This was taken by a human.
And it was color, too.
And it was in color. And people looked at that, and they said, oh, my God, look at the Earth. And this thin atmosphere that separated us from oblivion. And that's when the environmental movement started going. After people looked at that and realized how fragile an environment we lived in. And that was something. The other thing it did was, philosophically, was to realize that we could do marvelous things if we put enough effort into it. Most of you, at least the older people, will remember a saying, which is, you're reaching for the moon, which means you're trying to attain something that's unattainable. You're reaching for the moon. Have you heard that lately? Hell no. We've been to the moon, you know. Now it's changed so that if we can go to the moon, we can do such and such. In other words, we can do anything if we put enough effort in it. And that was, I think, a philosophical benefit from the Apollo program. And that still lives today.
And Ewen, I'll give you the last word, and then we'll turn it over to some questions. What do you think of your career in doing this? What image or images do you think struck you the most out of all of those? Or like Bob, were they all just special in their own way?
Well, I think really there's been such big steps right from the beginning that everything is new to us, or it was new to us at the time, and still is now that they're getting pictures of comets which are way out past Jupiter. Unbelievable that the way things have gone on. And I can remember right back in the earliest days of the Rangers going to the moon that people were saying, whoa, look at this. this crater's only 3/4 of a mile across. And now, of course, they can get very small thing. But I think the one thing that took my attention was Surveyor 3. Now, Surveyor 3 had a good soft landing. It landed roughly where they wanted it to go. And from the tracking from Goldstone in California, the radar, they could say it as these coordinates on the moon at such a latitude and such a longitude. But that was quite a large area. Now, before this Surveyor 3 went to the moon, one of the orbiters has got quite a lot of close-up photographs which are to show things on the moon which are only about 2, 3, 4 yards diameter or size. And with Surveyor 3, it landed, and then it was powered up with its electrical supply. And the first thing they did was to put one of the cameras on and have it at low power and take a very quick survey of what the camera could see as it was swiveled on the moon. Well, that worked all right, and the pictures came back from Goldstone in the desert there where they collected with a big dish, and they'd made a little mosaic of about 8 pictures taken by the surveyor. There were pictures like this, one there, one there, one there, one there. So they would all overlap each other and give you some idea of what the surveyor was doing, what it could see in the distance. Well, these were first pictures and they were not very clear. And the main things that could be seen was when it turned down to, well, it could be moved a certain amount, but it had a panorama which was from about there to there of the horizon. And it was obvious that the surveyor had landed on the horizon because the pictures were tipped a little bit. Anyway, in the pictures there was just a lot of hash, they were very poor quality. And there was obviously a little crater with its limb illuminated. There were 2 rocks further away with 2 little twin shadows, another somewhat larger rock with its shadow. And so, okay, they got the pictures from orbiter which had already been taken some months before and laid them out on the table, and these occupied an area of about 6 feet by 8 feet. And they said, okay, here's the area. We guarantee from our radar tracking from Goldstone that it's somewhere in this 6 foot by 8 foot mosaic of pictures which are laying on a big table. Who wants to try and find out by comparing the horizontal view with a little crater and the single crater and the two rocks on the single rock, where they are on the moon? They're somewhere. Well, this was a monumental task, of course, and in fact I timed it. It took me 23 hours of looking day after day to find out where this darn surveyor had landed. Anyway, I went around with this little magnifying glass. One of the guys who took pity on me said, here's a nice little magnifying glass, a souvenir of your search for surveyor. So anyway, I kept doing this. The others on my little team were Gene Shoemaker and one other fellow. They gave up in disgust immediately. So I was left with this job, and I thought, well, I'm going to darn well get it. And so I went around with magnifying glasses in all the craters, till finally I found one which had the vertical view, of course, of the crater it had landed in, of the little crater with its rim illuminated by the sun, the 2 rocks with their shadows, and the 1 rock with its shadow. So I could say, finally, you've got it, and told them, said, hey, he's found it. Imagine my surprise when some months later I got a letter in the Lunar and Planetary Lab here, marked the White House, I thought, the White House, what's all this? And I opened it up, and there was a one-page letter from Nixon, Tricky Dicky Nixon. Yeah. And he wrote very nicely, I've heard of the way you found where the surveyor had landed, and the way pieces were sawed off and brought back to this country, and congratulations on your job. So I thought, my goodness, what's Tricky Dicky? And it turned out that was the only one of these letters he wrote to the teams on Surveyor, because I knew the in-between between me and this fellow and Tricky Dicky. Pardon me, Tricky Dicky. But anyway, this was a great thing. And, well, I showed it to Gerard Kuiper. He said, whoa. So he rushed down to the end and got the secretary to say, hey, Ewen Whitaker's found out where the surveyor is on the moon. And it was, well, just part of my work, which I like doing, and it turned out to be quite a one-time thing. So I think, even though the pictures that came back were terrible with that first panorama, it was the start of getting pictures on the moon and looking at orbital pictures as well as the pictures from this surveyor. But of course, later that bigger steps were taken, and the orbiter pictures were getting better close-ups, and then we got all the stuff from Apollo, and so everything has been amazing all the time, from the Rangers way up to all the Apollo stuff. So that was my job for 27 years at the university here, Lunar Planetary Lab, and I retired. I've been retired 27 years too, so that's the match for you.
Well, thanks, Ewen. Yes, round of applause for Ewen. So we may have a couple minutes for audience questions. I don't know if we have a mic out there or if I... Go ahead.
So I'll just try to speak loudly so everyone can hear. So we're sitting in the auditorium of the Photography Center, and in the exhibition here, one of the sub-narratives is the role that photography has played in astronomical exploration. I'm just wondering, it's a question for the entire panel, is the role of photography in exploration, space exploration, still as significant today? And has it evolved? How and how?
Well, yes, it's significant today, absolutely. I mean, are you kidding? I mean, all I can say about that is absolutely it's significant, if not even more so today, because of the great camera systems they have these days. I mean, all you have to do is look at the comet from Rosetta, the Rosetta mission. I mean, that's fantastic. And coming up, I think next week they're going to start releasing pictures from the of Ceres.
Yeah.
And I mean, yes.
New Horizons will be on the coming up in July too.
And then look at
The HiRISE.
It was
The
somewhat
Alfred.
controversial early on. The space physicists dominated, and they thought you have to measure something. You know, you get a physical measurement. Pictures, you know, that just didn't fit. And the argument was made by certain individuals that, well, you take pictures and you make new discoveries. We can't tell you in advance what it's going to be, and that was a strange argument, but it won the day.
And I think photography and imagery is going to become more important as we go on in the future, particularly because there's an environment of increased budgetary pressure. And so at least one of the things we do with HiRISE is to image areas for future landing sites. So one of the consequences of this increased budgetary pressure is people being much more risk averse with the missions that they want to land. So they want to image, they just want to carpet image the place that they think that they might want to go to. They want to make sure there are no pointy things. There's nothing anywhere near that can possibly harm their spacecraft, their lander. Because if you only have so many dollars to spend, you're not going to put it down anywhere that looks even remotely hazardous whatsoever. So the role of imagery becomes even more critical because you're protecting your investment at that point. And you're protecting, if you're trying to scout out where your rover is going to go to. You don't want to send it through a sand trap. You want to try to get around that sand trap, and that's some of the things that you can do with imagery.
Yes.
Yes, I have heard that CCD images were very strongly influenced by astronomy, the need to image in detail. Is that the case? Has it been powered by?
Yes, absolutely. CCDs were developed by astronomers to get more precise images from telescopes, and then we adopted them to fly on spacecraft missions.
And Bob and Ewen, when you were up there on the mountain taking pictures through the 61-inch telescope, you didn't have any CCDs yet, did you?
No, we had what's called film.
Film.
Yeah. Yeah, we took a lot of it. It was all film in those days. I still have a film camera, actually.
Yes.
Robert Strom mentioned that the backside of the moon was totally different than the front side. Wow, how is it different?
It's different because the Maria, the dark areas of the moon, are concentrated on the front side. And there's probably a difference in the crustal thickness because of that.
So the dark side of the moon is the front side.
Yes, that's right. So that's the dark side. That's the Mare. The far out side has very, very few Mare. It's mostly heavily cratered. There's a few patches of it, but not very much.
Yes.
Yeah, there's Surveyor 1 and Surveyor 3. Can you remind us again what happened to Surveyor 2? It must have been something bad.
Surveyor 2 crashed.
As did one of the other ones, right?
Got closer and closer by the radar, and all of a sudden,
I think they alternated. All the even ones crashed and the odd ones succeeded until the very end when even ones.
That's right, yes.
It might have been the same problem that the Mars Polar Lander had, where it thought it had touched down and it shut off its engines when it was still too
That's
high.
one of many theories.
Theories, yeah.
Nobody really knows.
One day maybe they'll build a museum around it and figure out what happened.
Yeah, a question for the two pioneers here. What's the next big thing you'd like to see in this field?
The next big thing. Well, I'm waiting to see Ceres, which is next week, I hope. That'll be in Japan at the time, but anyway, I want to see that. But what else is coming up? Well, got New Horizons. I never thought I would live long enough to see every large body in the solar system. But if I can live until July, I will have done that.
Hang in there, Bob. We're
Those
pulling.
are the things I wanted to see, and I'll see them all, and I hope. But there's other things I'd like to see, of course, that I'm not going to be around to see. Turns out Titan is extremely interesting, the surface of Titan, and I'd like to see more high-resolution images of that. But there's other things.
To add to that theme, either Alfred or Kristin, say 10 years from now, HiRISE, MROs no more, and you could lead any mission the type that you wanted. What kind would you pick?
Well, I submitted a proposal to NASA for a mission to Bob's favorite place, Jupiter's moon, Io. So that's where I want to be. We'll get there in February of 2026.
These were the Discovery proposals?
It's a
That was you
Discovery
on that
mission,
one? Okay.
yeah.
What about you, Kristin?
Honestly, all of the outer moons are incredibly fascinating to me. They're so active and so interesting and so unique, and any of them. And honestly, if Titan wasn't in this solar system, the rest of them would be number one on my list for other reasons. But Titan is such a superstar. I mean, it's just it's incredibly fascinating. It's, yeah.
Yes.
So I'd like the pioneers and the current workers to kind of talk about this from a different generational point of view, which is that it seems to me that today we're living in a world for a number of reasons that has completely polarized information. So you have people who are scientific in their approach and people who are just not. And it seems to me that when I was young, I don't remember that there was a lack of knowledge. Not everybody was a scientist, but I don't remember that feeling of polarization and almost antipathy towards it. So I'd like the two groups to talk about that idea and how it fits into the broader social picture. Like, what does it mean that so many people no longer actually care about facts and instead put information, which is not the same as facts, together their own way?
Well, that's a good question. I wish I could answer that. I don't know. I think part of the answer lies in education. I'm afraid that the students are not getting the science education that they need to get. I go to Japan all the time, and it's over there. It's quite different. It really is. I mean, they have a good background in science, even though they're not scientists. I don't really. I don't think that's the total answer, but I think it's part of the answer. It bothers me. I guess it bothers you, or you wouldn't ask the question, and it bothers me as well. And I don't know what to do with it, about it. One of the things, the issues that has really polarized a large part of this country is climate change. I mean, there's no question that it's happening. Absolutely none at all from a science point of view, but people don't seem to want to accept that, or a large number of them. And it's more prevalent in this country than any place else. In Japan, for instance, 95% of the people there say yes. You know, climate is changing, and we need to do something about it. And here, it's only something like maybe 50%. So I don't know, but I'm sure you have other
That's all right.
opinions on it.
Changing the subject a little bit, getting back to the moon, because I'm a lunatic. There's one little object on the moon which deserves, I think, astronauts to go to. And if they ever do go back, astronauts, for any special reasons, there's this one thing. It's more or less in the center of the moon. It's in the outside of Mare Imbrium, which is one of the dark areas, which is surrounded by very high mountains, and then all the rubble that was thrown out and lava lakes and whatnot. One of the orbiters didn't do it, but the Apollo missions photographed lots and lots of the surface in high resolution. And there's this one little area sort of behind the Apennine Mountains, and it measures about 3 miles by 2 miles. And it's like nothing else that's ever been photographed on the moon. It's totally unique. There may be other places, but of course there isn't the high resolution picturing of the whole moon. But anyway, you look at this thing here, and it's just an area of the moon. There are no real craters on it, and there are a number of sort of globules of mercury on the surface. Now, I don't know if you've ever seen spilt mercury. It tends to, because it's got a big surface tension, kind of goes along in...
Talk about Ina D.
Mm-hmm.
Ina D. Is that the feature you're talking about?
Oh, that has been imaged by
I know.
the
Oh, well, I'm behind the times, you see.
So human
Anyway, as
mission
long
to
as they go to
IND is
this
what we're
thing,
talking here.
because it's the most peculiar formation I've ever seen on there, and the photometric function of different parts of this crater, because one of the Apollo missions had a very high resolution camera as it went across the surface of the moon, or across the beyond the moon. As it was going along, it would photograph like this with high resolution pictures where the resolution was down to about a few meters. And so you can see this thing from two slightly different angles, and you can see it in 3D. But even the photometric function is it changes on the mercury globules, as I call them, to the lower parts of this feature. And really, that needs to be looked into.
So we've covered that in stereo
it
with
has
the
been.
Lunar Reconnaissance Orbiter camera,
Yeah.
and it's a low shield volcano, and that
Yeah.
thing is at the summit of the shield volcano,
Yes,
and
yeah.
there's
it
probably
has been in-
inflated lava flows that
Yeah.
make those globules.
Oh, very good. That's
You-
the worst of being.
I'll send you a paper.
Oh,
Yeah.
I'm out of the circle these days.
So on that note, I think we're out of time here. Do one of you want to take over?
Let me ask the audience a question. How many of you know that there was an Apollo, let's see, 18, 19, and 20 that were planned? You knew that and they were canceled by your tricky dick.
Yeah.
Okay. All right. Because at the time of the Apollo mission, we were convinced that after Apollo, we were going to go to Mars and land humans on Mars. I mean, that was the plan and everything, and it was going to happen. And boom, it was all canceled. It was one of the biggest disappointments of my life. Sorry.
No worries.
Yes.
So I came into tonight expecting to be educated, but I had no idea these guys were so hilarious. So another round of applause, please, for our panelists. Thank you so much. So I'd like to take the opportunity to invite you to our fourth and final program for Astronomical. It's happening 2 weeks from today, Thursday, April 23rd at 5:30 here in the auditorium. Adam Block of the Mount Lemmon Sky Center will speak about the future of astrophotography. So it's going to be a great program, and we hope you can attend. And thanks for coming out tonight.